It surrounds us every day, but do we truly understand how they work? What are sound waves? How do we as a species use them? And how does the world around us use them to communicate? From elephants to spiders, we will discover how certain animals communicate with each other and their surroundings.
What is a sound wave? By dictionary definition, they are longitudinal pressure waves in any material medium, regardless of whether they constitute audible sound. To help understand what a sound wave is, it might help to know these key terms. First is wavelength. It is the distance from the crest of one wave to the crest of the next, the crest being the highest point of the wave. Frequency is the number of waves that pass a point in each second. It is the difference between a high pitch and a low one. Amplitude is the measure of the amount of energy in a sound wave, so a yell or roar would have a higher amplitude than a whisper. And last is medium. Any place where a sound wave can travel, like the air or through water. So when put all together, a sound wave is emitted from anything that makes sound, whether or not we as humans can hear it. The sound wave travels through space or a medium and spreads in all directions. If the sound is very loud, like a jackhammer, the amplitude is very high. If the jackhammer hits a pipe, it would make a very high-pitched sound, making the frequency jump and the wavelength shorter. If the sound emitted is a hum, the amplitude and frequency will be much lower. Notice that the sounds of lower frequency and amplitude can be much more pleasing to listen to than that of a jackhammer. Now that we have an understanding of sound waves, we can begin to learn how animals use them to talk, see, and hunt for food. Have you ever heard the expression, blind as a bat? Well, the myths are true. Bats are almost completely blind, but they are one of the best nocturnal hunters in the world. How is this possible? Just a little thing called echolocation. It is the ability to locate objects by bouncing sound waves off of them, and then measuring the time taken for an echo to return and calculating the direction the echo came from. Bats use echolocation to find their way around in the dark and to locate their food. They send out high-pitched sound waves, which they create by using their mouth or nose. When the sound is emitted, it hits an object and an echo bounces back to the bat. This allows bats to see with sound. Most bats produce echolocation sounds by contracting their larynx. Other types of species click their tongues. These sounds are generally emitted through the mouth, but horseshoe bats and Old World leaf-nosed bats emit their echolocation calls through their nostrils. There, they have basal, fleshy horseshoe or leaf-like structures that are well adapted to function as megaphones. With these echoes, the bat can identify the location, size, shape, and even the texture of the object. This allows bats to have the ability to hunt and find their food in pitch darkness, making them one of the most fearsome creatures of the night. Argued to be the smartest mammals on the planet, dolphins also use echolocation to navigate through the ocean. Some dolphins, like the ones that live in the Ganges River in India, don't have lenses on their eyes at all. Yet they have the ability to see for kilometers in the river. How does this work? They rely once again on the ability that almost all cetaceans are masters of: echolocation. Sonar. Its entire head is built on an array of sending and receiving equipment. The dolphin makes clicks near its blowhole, and then in a fat-filled cavity in its forehead, called a melon. The sound is guided into a narrow beam. The sound is sent out in a series of short pulses. The echoes that are reflected back are heard through the dolphin's lower jaw. which is connected to the ears. It's as good as vision, and in some ways, better. Some bottlenose dolphins have the ability to see through the sand. This makes them outstanding predators towards small fish. If you think that this ability seems sophisticated, well, that's because they've had 20 million years to adapt and perfect it. Elephants, known for being the animals most like humans, next to monkeys, of course. Elephants communicate with what is known as infrasonic sound. They are sound waves so low-pitched that the human ear cannot hear it. If you ever wondered why elephants have such large ears, it's because they need them to hear the low-pitched sound waves made by their fellow elephants. Elephants can produce a range of sounds, varying from low-frequency rumbles to high-pitched trumpets, snorts, barks, roars, cries, and other calls alike. Because the sound waves they create are so low-pitched, they are able to travel much farther than high-pitched sound waves, kilometers farther. Here, the elephants are sensing a disturbance. It could be their only known predator, and they must be cautious since they have a young calf with them. Being careful not to step into enemy territory, the elephants continue to move north while sending out signals warning any other potential predators. Spiders. Their only predators being a pair of steel-toed boots owned by the brave. Arachnids are another species to use sound waves as a way to hunt. But instead of listening, they feel. Spiders spin their webs between branches or on bushes, and when they're finished, they wait. Quietly. Eventually, something will land in the web and make tons of vibrations. The spider, knowing its home, will navigate through his sticky web stealthily until he finds his food and wraps it into a cocoon. Spiders completely rely on the vibrations bugs makes while slamming into their web for a meal. Without sound vibrations, spiders wouldn't exist. The speed of sound varies depending on where you are. That doesn't mean sound travels slower in Philadelphia than New Jersey, but it does mean sound moves much more quickly through a solid than through a gas or liquid. A sound wave can travel about 343 meters per second in the air. That's about 750 miles per hour. That is extremely fast, but when you compare it to the water, well, there's no comparison. Sound in the water can travel at a speed of about 1500 meters per second. That's more than 3300 miles per hour. The reason for this lies in the particles. In a liquid, the particles are much closer together than in a gas. So sound traveling from particle to particle will move faster if the particles are close together. This also holds true when looking at a solid. This chart clearly demonstrates that the denser the object, the faster sound can move through it. It is also important to note that as the temperature increases, so does the speed at which sound travels. This is because as the molecules heat up, their collision grows, packing them closer together, and allowing sound to travel faster through them. It is also important to understand that the speed of a sound wave through a medium does not depend on the frequency of the wave. Just because something is higher pitched, that doesn't make it faster. Now, it may be counterintuitive to think sound can move through a hot piece of granite faster than the air, but we must remember that sound travels on a molecular level, something scientists are still learning about today. Quiz yourself. Based on what we just learned, if two dolphins in the water and two bats in the air were equally spaced apart, and at the same time one dolphin and one bat send a sound wave to signal their significant other, which animal would receive the wave sooner? Answer: the dolphin. Remember, sound travels much more quickly in water than it does through air, because of the spacing of the particles. Question number 2. If infrasonic sound waves are waves that are too low for humans to hear, then what does ultrasonic sound mean? The answer: higher than what humans can hear. Bats use ultrasonic sound to communicate. We have just learned about how 4 completely different animals use sound waves to achieve the same goal: communication, vision, and hunt for food. Without this basic sense, even us as humans would be silent.